Well, good morning.
Good morning, sir.
Yeah. So in the last class, we were discussing about bookmaking process to non-recovery cocoa ones, and we were seeing the video which is showing the complete process of bookmaking to non-recovery cocoa ones. So we'll just continue that video before we proceed for further discussion. So in the last class, we have seen that whenever we subject the coal cake into the cocoa ones, once the coal exposed to the oven temperature, then the volatile matter which is present in the coal will start expelling out, and that will be that the volatile matter will get combusted inside the cocoa one at the free space, and these gases after combustion they travel to the downcomers, and it will pass through the sole pipes from the bottom, and it will travel from one end of the oven to the other end of the oven, and that is how the cooking basically takes place in the non-recovery cocoa oven, both in bidirectional. Means the top surface will be subject for the cooking, and also the bottom part, because of these gases which are traveling through those sole pipes, because of which the bottom part also will undergo cooking. So in that way, this bidirectional heat transfer basically takes place, and due to which the cooking process takes place effectively. So this is the advantage of non-recovery cocoa oven compared to that of the beehive kind of cocoa ovens which are Adam now. So what happens inside the coke ovens? See, as I said, that metallurgical coals, when you subject for the coke making process, these coals not only undergo chemical changes, but also it undergo physical changes. So such kind of coals we usually subject for the coke making process. So when you subject these metallurgical coals to the coke making process, they basically undergo softening, swelling, and then it transforms into semi-plastic, and then completely it will be plastic in nature. So this transformation basically takes place inside the cocoa ovens. Okay. and this will take place over the duration of time as the temperature is increasing. So once you are subjected the coal into the coke ovens, from temperature of around 0 to 300, if you see the moisture content, whatever it is present in the your coke, that will be expelled out, and from 300 to 600, complete volatile matter, whatever it is present, that will be comes out, and from around 900 to 200 degrees centigrade, the coal will convert into a hard porous mass, which is called as a coke. So this is what actually happens inside the coke ovens over a duration of around 65 to 70 hours. When you subject the coal for the cooking process, this is how the transformation of coal to coke basically takes place. We have seen this process that from one end, with the help of a plunger, they are pushing the coke, whatever it is prepared in the coke oven, and that coke is in the red hot condition, and they are coming out and collecting in the pinch card. You can see uh, the red hot coke which is coming. So the other end, the plunger is moving into the oven, and it is pushing the entire coke which is present inside the coke oven. So you can see collecting pipe here. Okay, so whatever the heat which is gas which is present inside the oven, that gas will travel through the side walls, and it travels through the downcomer, and then it will pass through the sole pipes, and the bottommost part also will get heated up. Okay. And the waste heat, whatever it is there, that comes out from the oven, and it is collected in that collecting pipe, which is there at the top of your oven. So now we are removing the plunger out from the coke oven. Now the oven is completely empty, and it is ready for the next whole cake to be subjected into the oven. And the red hot coal coke, whatever we have collected in the quench car, that will be moved towards the quenching tower, where we use water as a media, and then we allow the whole cake to get cooled down. Okay. So there are two methods are there. Quenching can be done both by dry method as well as wet method. But here in our plant we are using the wet method of quenching, where we are using water as a media. Now this coke has came under the quench tower. Okay. Now there is a water sprinkling jet is available at the top. You can see in this particular video, water sprinkling is started. Okay, and sprinkling will be done in a cyclic manner. There is a sequence is there. Okay, so based upon that sequence, like quenching, Yes, the water is now, you see, the water is allowed to fall onto the quench cake, onto the cook. Quenching is going on. Huge amount of fumes are generating. This is one of the disadvantage with the wet quenching process. Enormous amount of heat is getting extracted from the coke, but we cannot able to utilize that heat. It is simply getting waste. This is what happens once the coal is charged into the coke ovens. The coal absorbs heat from the refractory material, and that will helps in the evolution of the volatile matter. And this volatile matter, whatever expelled out from the coal, will undergo combustion through the air which comes in contact with it through your the front as well as the top ports. I have shown you the previous slides. You see, there are some ports which are present. You can see these are the ports. Okay, from the front side, and similarly across the length of the oven, also the top surface, you have some ports are there. This is for the air to pass through. And the kind of environment inside the ovens, if you see, these ovens work under negative pressure, so there is a continuous suction is there. So because of that, the combusted gases, whatever are present in the free space inside the ovens, these gases undergo suction, and it will travel through these downcomers. And from these are the sole pipes. You can see these are the sole pipes. From these sole pipes, it travel across its length of the oven. Okay, so you can see here, this is the bottom surface scenario. So how the heat is traveling across the length of the oven, you can see. Okay, and then it comes out from the other end of the oven. So in this way, there is cooking is happening at the top surface, and also because of the heat is traveling from one end to other end through the sole pipes. So the bottom part of the bottommost part of your coal bed is also undergoing cooking process. So in that way, the bidirectional mode of heat transfer is taking place, because of which the cooking takes place effectively. So so what happens inside the oven? Just now I told you that when the cooking is happening, how the coke behaves inside the oven, physical changes take place inside the oven along with the chemical changes. If you see, temperature of 0 to 300, we will be having an evolution of moisture as well as increment of VM takes place. And from 300 to 700, you have the complete expulsion of VM takes place. And from 900 to 1200, you have a solid porous mass is formed, which is nothing but the coke. Strong coke is formed. So, whole cake, whatever we are subjecting for the cooking process, that is having a weight of around 50 tons. Thus, the stamped whole cake having a 50-ton capacity, and that whole cake, when you subject for the cooking process for a duration of around 65 to 70 hours, and that will give coke of around 35 kgs. Means in and around 15 kg of VM is getting expelled out. So once the cooking process is completed, then the doors of the ovens are mechanically lifted, and we have seen in the video how we are that plunger is used for pushing of the entire coke from one end to other end, and it is collected in the bench cart. And this red hot Coke is subject for the quenching process using water as a media under the quench towers. So while quenching also, there is a proper quench cycle which is followed, that you can see here, that we don't allow continuously sprinkling of the water. Rather, we follow this cycle, that is 140 seconds quenching, and then you give 3 minutes rest. And then again you start flushing water for around 135 seconds, and then again you allow it rest for 3 minutes. And again 60 seconds you allow flushing of water, and then finally you just leave the coke for the further cool down. So the reason why we are giving this resting time, because resting time is given so that this moisture, whatever is getting, or the water, whatever we are sprinkling on it, so that will completely get absorbed by the coke, so that the coke will be cooled down. Because red hot coke, whatever is coming out from the coke ovens, we cannot transport it. It is quite difficult to handle this coke for the transportation process, because conveyor belts will get burnt off. So to transfer this coal cake from the quench tower to the crushing unit, so we should cool down to the room temperature, and then only we can handle it, or we can transport it to the conveyor belts. Sometimes what happens, even though we are provided a proper quenching cycle, but still a certain amount of coke will be still in the burning condition. So in that case, manually we sprinkle the water by using some pipe, and we sprinkle the water so that the coke will cool down. Yeah. So this is what the sequence of operations we undergo. So whatever the coke which we obtained from the oven, that will be sent to the quenching towers, and here the quenching process is happening. And then after quenching, this quench cart will be get empty by racking. You just tilt it so that the entire coke will be racked down. Okay, and this is the area where your coke will be residing, okay, for cooling purpose. Now, whatever the coke which you obtain, if you subject for the analysis, then you can find some of the properties here. Like we have seen previously, the chemistry of coal. Coal, whatever we are subjecting, this is the chemistry of the coal, what we are about to subjecting for the stamping process to make a coal cake. Okay, here you see, before the coal is subjected for the cooking process, the VM is around 22-24%, and the FC fixed carbon is around 66 to 68%. Okay. But whereas once the coal is subject for the cooking process, now you see what is the VM. The VM is just 0.6%. So during the coke making process, the entire volatile matter is expelled out from the coke. And also, if you see the FC, the fixed carbon, initially it was around 66 to 68. Now it is enhanced and increased to around 87 to 88%. We have discussed in the previous classes that the coke, whatever we are subjecting for the PF process, should have at least 85% of FC should be there. Okay. So, and also, if these coke, if it is subjected for some mechanical testings, okay, certainly we do, before we subject the coke as a raw material into the blast furnace, we do some testings and found out that the M40, that is Micom index, M40 and M10 is around 86 to 89 and 5 to 6. Then you can also see the CSR, that is the coke strength after reaction, it is around 65 to 67. And the CRA, that is the coke reactivity index, that is 24 to 26. So whatever the coke which we obtained from the ovens after cooling, the size of the coke will be of around approximately 120 mm size. And this coke, after getting cooled down, it will be transported through the conveyor belt for the sizing process. Okay. They use cutters. They have coke cutting machines are there. You can see in this particular picture the rollers. So they allow the coke to pass through these rollers, and the crushing basically takes place. Okay, and then first product, whatever it is, that will be screened at different sizes, and based upon sizes, they will be used for the various applications. Okay. So for blast furnace, a size of around 25 to 80 mm of coke is basically used with a mean size of 52 to 53 mm, and around 10 to 25% mm, 10 to 25 mm size of coke is also used in the blast furnace, which is called as nut coke. And anything which is less than 10 mm size coke, and that is used for the sintering process. You see the advantages and disadvantages of non-recovery coke oven process. This method requires less capital, and it is capable of producing coke for metallurgical applications. This method uses exit gases for heat recovery, and certainly that will generate electricity through the steam. And this works under negative pressure and does not release any hazardous gases into the atmosphere. Pollution is very, very less compared to that of byproduct of oven process. The limitations are we cannot able to recover any byproduct from this process, because the entire whatever the gas which comes out, that is again combusted within the oven itself. So we cannot expect any byproducts from this particular process. Now we will see the another method of producing coke, that is by byproduct coke oven process. In the name itself, it is a byproduct, means apart from coke, you can expect some other products from the waste gas which comes out from this particular process. So here, the difference between non-recovery and byproduct coke oven process is that there is a difference in the design of the oven. Dimensions of the oven is something different. Here, the oven is relatively narrow, and they are vertical rectangle chambers. Since the ovens are heated from outside, the heat required for the carbonization is transmitted through the side walls. The oven widths are restricted in order to achieve the uniform heating within the oven chamber. But if you are restricting the width of the ovens, and to improve the productivity of the ovens, the only option is to increase the height of the ovens. That's why the height of the ovens are relatively is larger compared to that of your non-recovery coke oven process. And the dimensions of these ovens, if you see, are typically of around 400 to 600 mm wide and 3000 to 1400 mm long, and its height varies from around 4 to 7 meters. And every oven will be having two heating chambers side by side. For the carbonation process to take place effectively. And the charging process also, we have seen in the mechanism of how we are charging the stamped coal cake into the coke ovens in the non-recovery coke oven process. Whereas here in byproduct coke oven process, the charging system is something different. Here we are going to charge the coal from the top of the ovens. You can see there is a small video here which shows how the charging will be done into the ovens from the top. Okay. So these are the manhole, the charging holes from the top of the oven. We have a series of oven charging holes are there from the top. You can see across the length of the oven. Yeah. Here also, just like how we have seen in the non-recovery coke oven, where during stamp charging process, there is a bunker and there is a railway moving system where from the bunker your coal is charged into the stamp charging machine. Okay. Similarly, here also there will be bunker, and there is a movable bunker through the rails. You can see here, yeah, this is the rail. Okay, so on which the so this is how charging will be done. You can see here how the lid of that oven is removing. But also you can see here in this particular video. Yeah, now you can see here. Yeah, the lid is open, and this is the bunker. This is the bunker. Now this will be lowered down. Now the charging is taking place. Now you see the some gases are coming out. There is some charge. There is charging of coal is taking place inside the oven. So this is how the top charging basically done inside the oven. So here also we use hole size of -3 mm. That will be charged mechanically through the charging car. This is the pictorial overview of a byproduct coke oven process, where you can see there is a series of, as I told you in the previous class also, a series of ovens are called as a battery. So here also you have a battery where a series of ovens are arranged. Now here, heat transfer, it is taking place from the side. Rather, in the previous process we have seen, it is vertical. The heat transfer is taking place bidirectional in the vertical form. But here the heat transfer is also taking place in the bidirectional, but in the horizontal. Yeah. So this byproduct cocoa oven process basically works on regenerative principle. You have a heating chambers sides, and the heating chambers works on the regenerative principle. So these heating chambers provide heat for coking the coal in the coke chamber, and the heat is combusted through the silica walls. The heat energy is obtained by combusting the gaseous fuels in the flue pipes with preheated air. Okay. So the coke oven heating generally uses a mixture of oven and BF gas. Sometimes the producer gas is also used when the coke oven and blast furnace gas is not available. Okay. So yeah, so at the bottommost part you have this combustion chamber where this works on the principle of regenerative principle. So the gas and the hot air is combusted in the vertical flues in one of the heating chamber, and the hot gas escape through the adjoining heating chamber, and this cycle is reversed after a certain period. Keep uniform temperature in both heating chambers. Okay, so you can see this is the coke oven. Below the coke oven, this is the regenerator. There you have a checker bricks. These bricks are aligned. Okay. And whatever the heat is generated within the oven, that heat is passed through these checker bricks, and the checker bricks will get heated up. So the regenerator are heat exchanging devices to recover this heat from the outgoing hot gases, and that will be used for preheating the incoming cool air to get high temperature in the combustion chamber. So this is what the regenerative is. The hot air, whatever is coming out, hot gases which are coming out from the oven, that will be sent to the checker bricks, get heated up, and from the ambient atmosphere we suck the air, and that air is allowed to pass through this hot checker bricks, and that is how the heat is maintained. So when one heating chamber is getting heated by the outgoing gases, and other supplying, and one will be in the on gas, other one will be in the on blast kind of situation we'll be having. Okay. So in this way, the heat will be circulated. In this particular picture, you can see this heat is circulating. Okay. So the hot gases which is coming out from the one end of the heating chamber, so that will go down and gets heated up the checker bricks, and then whatever the air, whatever you are sucking from the outside,